So
So we'll do a 30-minute and then, yeah.
what are we going to do today?
I just have a couple problems today, and
Okay.
then we can stop.
Okay.
So let me find them. They're on my phone. I took pictures. Okay, so the one I have is y equals x squared minus 2x plus 5. But hold on, I have to look at my notes to see what we're supposed to do with this.
Probably solve it.
Yeah, it's like a...
Find the zeros. And the only reason I say that is because we're going to have to use the quadratic formula to do that.
True. I'm just looking. There's a name for it. I think I don't know if I think it's focal distance.
Ah, so you're into conic sections.
Mm-hmm. So yeah, it's focal distance in like the ellipse of a circle.
Okay. So when you study quadratics as parabolas in algebra, they don't treat them as conic sections. But when you get to conic sections and you realize that a parabola is a conic section, then the thing that becomes important is the distance to the focus from the vertex. And that distance right there is P, the focal distance. And it's extremely an important point inside of a parabola. That is where every ray coming into that parabola reflects to that point. So if you go outside and look at dishes on the top of people's houses, they have a receiver. They're in the shape of a parabola, and they have a receiver a ways away from the vertex. And the reason is that anything that comes in from a satellite feed, or whether you're looking at stars in the sky, gets reflected, all of it, to that point. So you put your receiver right there. So the focus of a parabola is extremely important. Now, when you start studying parabolas as conic sections, they give you a different format for it. And what it is 4p times the variable that is not being squared equals the variable that is being squared, as opposed to the format that they originally taught you, which is y equals a times x minus h squared plus k. This is what you learned in Algebra 2, called Vertex Format. And it immediately identified the vertex. So if I wanted to take this quadratic that you've given me here and put it into vertex format, I could. And the way you have to do it is completing the squares. And that's not a bad idea to do, just because I know you're familiar with it. So let's take that. Let's ignore this for a moment. I don't know whether you've even been taught this format yet. Have you?
I don't think so.
Okay. That's fine. We can work entirely in vertex format, but you have to know A is equal to 1 over 4p, where p is that focal length. Some schools never do switch over. In other words, they don't switch to this new format here. But if you apply that, you will see these are the same. In other words, those two are the same thing, as long as A is equal to 1 over 4p. So let's work in vertex format. So our job is to get this equation into vertex format. And let me scroll down here a little bit. Once we get it in vertex format, then we're going to be able to figure out what p is. Oops.
Okay.
Hold on a minute. Let me close my door. Okay, let's talk about completing the square. You know how to complete the square with this quadratic? We want to make it look like that.
Okay. So what do we have?
Well, first of all, you separate out the two variables, or the one variable, leaving space to complete the square. And the goal here is to make sure you go from row to row without changing anything. So far, I have not changed anything. Agreed?
Yes.
Okay. Now complete the square inside the parentheses.
All right. Well, like, what would we add to complete it? That would be just.
The way you complete the square is you take half of this coefficient that is x, this coefficient, 2, and you square it and you add it. So if I take half of 2, I get 1. Square 1, I get 1. I added it, and to balance everything out, I got to make sure I subtract the equivalent amount. And now notice that that's the same as that. It's just been some manipulation. I haven't changed anything. Always what to look for. Now, the reason we complete the square is so that I can write the stuff that's inside the parentheses as a binomial term squared. I can now write that as that. That was the entire point that I completed the square. I combine those two numbers, I get plus 4, and now I've got that. That's the same equation as we started with. The difference is it's now in perfect vertex format.
Okay.
So
where did the x squared go, though?
Right here, that's x minus 1 times x minus 1.
I see it.
Produces x squared.
Okay.
That's the reason when you complete the square, you will always be able to write it as a linear term squared. That's the reason you do it, is so that you can write it. This is a linear term, and we're squaring that linear term. And you'll always be able to write it as a single linear term squared, which is vertex format. Okay? Now, that's in vertex format. Tell me what A, H, and K are.
Is A 1?
Huh?
And then H is 2 or negative 2?
No. What's being subtracted from the X?
1.
That's what H is. What's K?
Okay. 4.
H and K are the vertex. In other words, my vertex for this quadratic is at 1, 4. More importantly, that's not what they ask for. They ask for P. Well, you have to go over to this equation. Substitute A. 1 for A equals 1 over 4P, and solve that for P. Well, that means 4P would be equal to 1, so P is equal to 1/4. And that is your answer. The focal distance is 1/4 unit above the vertex. In other words, if I were to graph this, pretty easy to graph a parabola when you start with the vertex. The vertex is at 1,4 right there. I know it goes up because A is positive, so it's a parabola that looks like that. Furthermore, I know there's a focal point right there that is 1/4 higher. In other words, the coordinates on that point are 1,4 1/4. That's where the focus is. If I was building a dish to collect signals off of a satellite in the sky, I would put the receiver 1/4 of a foot from the vertex up vertically. And that's where all of the signals would be focused on. In other words, the true value of parabolas really comes in conic sections. We have a lot of things in life that depend on this reflective property of a parabola. It's the way all telescopes are built. It's the way receiver dishes are built. It's the way flashlights are built. You're building a flashlight, you're using a parabolic surface with the light bulb right there at the focus. What happens is every ray from that light bulb hits the side of the parabolic and goes directly perpendicular out. That focuses the light. So it's not just shining every which way, it's all shining directly out, which maximizes its light intensity. So this position of the focus for a parabola is that's huge. That's more important than even thinking about it as a quadratic. Now, if they gave you the other formula, it wouldn't really change much. We would still have to complete the square because the whole thing is you want to define that term as a binomial square. It's just you would do it a little differently. And there's no need to actually go to this formula. I have mixed feelings as to whether I even like them teaching it that way. Seems to me that it just confuses the student because it's an entirely different looking format. There's no A in it, and there's this thing called P. So if you're used to vertex format, stick with it, but understand that you have that also. A is equal to 1/4P, which means P is equal to 1/4A also. So as long as you know, you can figure out P.
Okay, cool. Thank you. Honestly, that's like all I've got for right now. I'll tell my mom to like get the money to be sure, and we can start again tomorrow. Hopefully, if I get it in today.
That's fine. I mean, and you know, if she doesn't have money in a PayPal account and she wants to send a check, that's fine also. But I need to hear from her. I need to hear something.
Okay.
To hear that yes, I sent the check out yesterday, or I sent it out today, or whatever. But I can't just have nothing.
Okay, I'll make sure to let her know that she needs to talk to you.
Multiple invoices. All right, Merrick. I will talk to you. I'll go ahead and just cancel out the rest of the day and wait to hear from you.
Okay, sounds good.